Okay, so this is the multiple choice questions for the grade 11 cumulative exam. So I'm going to go through the multiple choice first, and I'll do each of a question as a separate video. So the first one was testing you on topic 1, and it's asking you what quantity has a fundamental SI unit of kilograms meters per meter per second squared. So when I start looking at this, I start seeing things like, well, kilograms. I'm already thinking in terms of, like, usually at this point, force, momentum, and pressure. Again, things like per seconds squared. Again, I'm thinking, well, there must be some sort of like acceleration going on. So again, could be thinking in terms of like force maybe, or pressure. In this case, because pressure is still force over area. And then usually by this point, I start kind of just writing down what my answers are. I already know actually that force is kilograms meters per second squared. So I knew it wasn't this one. So I went in and I did pressure is equal to force divided by area. So that's newtons divided by meters squared. Now, newtons, so force, is actually mg, all right? So we can use that in this case. Now, mass is kilograms, and g is our acceleration due to gravity, so meters per second squared. Again, if I plug all those in, so I have kilograms meters per second squared, I can cancel my meter with my meter squared down here. So that leaves me with kilograms meters now to the -1 and seconds to the -2. The next question then was also a topic 1 question, and it was asking you about uncertainties, and it's using the idea that when you've got a division, okay, so if we have any sort of division or a multiplication, we always add the fractional or the percentage, so the fractional uncertainty, or we add the percentage uncertainty. Okay, so in this case, density is mass divided by volume. So my mass is 8%. So I'm going to do my 8% added to my volume. They haven't given me the volume though. They've given me the length of the cube. So I have to cube this. So I have to do 3 lots of the 4. So 8 plus 4 plus 4 plus 4. So 8 plus 12. So that gives me 20%, which is down here. So just remembering whenever there is a division or a division or a multiplication, we have to add the percentage uncertainties with that. And this one was a little bit more confusing because it gave us just the length rather than giving us the volume. Question 3 was about a cube sliding down a ramp at a constant velocity, and constant velocity is really important, okay, because that means that there is no resultant force on it. It says, what's the magnitude of the frictional force acting on the slope? I say acting on the cube as it goes down the slope, sorry. So if I'm looking at a free body diagram of this, okay, I'm just going to be looking at the component I'm dealing with. The frictional force is trying to slow it down, and the mg sine theta component is trying to pull it down, the slope there. Okay, so these have to be balanced, so these two are equal. So the frictional force in this case equals the component of weight parallel to the plane, so that mg sine theta. The next question, for question 4, was asking about terminal speed, okay, or terminal velocity. And it's asking, in this case, she opens up her parachute. So again, she opens up her parachute. We suddenly have lots and lots of air resistance acting upon the skydiver. It asks what's the direction of her velocity vector and the direction of her acceleration vector when she reaches the new terminal speed. Well, the velocity is always going to be acting down because she is always acting downwards. Now, because this case we've opened up the parachute, we've suddenly got lots of air resistance, so our resultant force is now acting upwards, which means our acceleration vector is also acting upwards, okay? So in this case, it was C. The next one then for question 5 was a boat with an output engine power of 15 kilowatts moves through the water at a speed of 10 meters per second. What is the resistive force acting on the boat? So in this case, power is force multiplied by velocity. Okay, so force is power divided by velocity. So 15 kilowatts divided by 10 is 1.5 kilonewtons. So just a really easy calculation for this one. The next one we had was an elevator problem, and it was asking for what is the tension in the elevator cable. So with this one, again, I drew the free body diagram on the side. We've got tension pulling it up, and we've got weight pulling it down. We also know that it's accelerating downwards at 2 meters per second, which tells me that the resultant force must be acting in the down direction. Okay, so in this case, tension has got to be weight minus the resultant force. So at this point, I now need to calculate and find out the size of these different forces. So resultant force, F equals ma. So I do 750 multiplied by 2. to get 1,500 newtons. My weight, okay, in this situation is the 750 kilograms, multiplying it by 10. It's a multiple choice question, so we can use 10 here to get 7,500 newtons. To work out the tension then, I simply subtract the resultant force away from the weight, which gives me 6,000 newtons, which is 6 kilonewtons. 7 was an inelastic collision occurs between two bodies in the absence of external forces. Now, inelastic collision means kinetic energy is not being conserved, but we know these bodies are colliding with no external forces on them, so momentum must be conserved. So in this case, only momentum is being conserved. 8 was asking about thermal physics, so we were looking at topic 3, and it was asking about the internal energy of the substance and the potential energy, and we were going from a solid to a gas phase without becoming a liquid. And it was at this point it was talking about the potential energy when the phase change occurs. So during a phase change, all right, we are increasing potential energy because we are breaking those bonds and we are moving them further apart. So with this one, it has to be one of these two here. Okay, so C or D. We then think about the internal energy of the substance. Well, internal energy is potential energy plus the kinetic energy. Kinetic energy is staying the same. They're staying at the same temperature, but potential energy is increasing, so internal energy is also increasing. Question 9 was also on thermal physics, and in this case it told me I had a mixture of helium and oxygen at the same temperature. Same temperature means their kinetic energy is exactly the same. Okay, we have a molar mass of 4 grams per mole and 32 grams per mole. It says, what's the ratio of the speed of helium to the speed of the oxygen molecules? So I went in here and I used my kinetic energy equation. So I've equated the two because they're at the same temperature. So the kinetic energy of the helium molecule has to equal the kinetic energy of the oxygen molecule. So half mv squared. In this case then, I've just simply added in their molar masses for the mass. So I've got half 4v squared, half 32v squared. So that leaves me with 2v squared equals 16v squared. Again, to put it back into the ratios of helium over oxygen, I've got v of the helium squared divided by v of the oxygen squared is equal to 16 divided by 2, so that's equal to 8. Now, because this isn't the square of them, it is just them, I need to then root, so I get root 8 for this one. For question 10, this was looking at specific heat and latent heat, okay, and it was asking you for which of them were greater, looking at these two for y and x. Now, immediately we can see that it takes much longer for y to go through its phase change, which means it has to have a greater latent heat value. Remember, Q is equal to ml. So in this case, y has got to be greater than x, so it's either C or D. So I start thinking then about the specific heat capacities, and we have to think about the gradient, and we know that the gradient can be used to work out the specific heat capacity. Now in this case, we've got Q is equal to MC delta T, okay, which is equal to VIT, if we were using the experiment to work this out. So if I use this, change in temperature is equal to VI over MC, okay, multiplied by T. In this case, the gradient is therefore proportional to 1 over the specific heat capacity. So if we can see here, we can see that y has a less steep gradient, which means that its c has got to be greater. X has got a greater gradient, okay, which means therefore that its c value must be smaller. So in this case, cy is greater than cx. We then had another one of interpreting a gradient. For this one, we were using the ideal gas equation. So for this one, we said PV is equal to nRT. So if I was to put it in this relationship here, I've got V is equal to nR over P, okay, multiplied by T. Now looking at this though, I can see that none of my n's are little n for the number of moles. They're actually the number of molecules. So I look and I think, right, my number of moles is equal to my number of molecules divided by Avogadro's. So I put that in and I get nR over Na P multiplied by T. Again, that has not been given to me as an option, but I have got Kb up there. Now we know that R divided by Na gives me the Boltzmann constant. Okay, in this case, that becomes NKbP over T, which is question C. For the next one, then we started looking at waves, and this was a nice little question which was asking me about interpreting a transverse wave. So it's given me lots of different information here, and I've got to figure out which is the correct statement. So I start looking first of all at which ones are incorrect. So I usually start at A, B, and try and work my way down. Okay, particles at x and y are in phase. Well, x and y are not in phase, they are out of phase. They are pi out of phase. They're doing the opposite. Okay, so that's not true. The velocity at x has got to be a maximum. Well, that's incorrect because it's maximum displacement. At maximum displacement, it's at its minimum velocity, so it's at 0 at this point. Next one that says the horizontal distance between x and y is 3 meters. Well, I don't know that. I can't figure that out. So I haven't got that written down. So I have to do something to figure this out. So I've been given here the frequency of the wave and the speed of the wave. So what I'm going to try here is then work out what the wavelength is. So V is equal to F lambda. So lambda is equal to 100 divided by 25, which is 4 meters. Now, going from X all the way to Y, I've actually gone, okay, 0.75 lambda here. Okay, going over to there would take me to a full lambda. So I've gone 1.5, I've gone 3/4 of a wave along. Okay, well 3/4 of 4 is 3. So in this case, that is equal to 0.75. So that tells me that C was correct. The next one then as well was another waves question, and it was asking you to show the variation of the time, shows the variation of the time of the displacement of the particle of a travelling wave. We're going to be look here as well, we've got these at 10 to the -6 going on. So it's asking what the frequency is and what the amplitude is. Okay, amplitude is a really nice, easy one to quickly do. All right, amplitude is going from our displacement to our maximum, so that's 2 micrometers. So it's got to be A or it's got to be C. To then do my frequency, I've got to do 1 divided by the time period. Now in this case, I'm doing 1 divided by 20 times 10 to the -6. Now I didn't do that 10 to the -6 in my head. I just did 1 over 20 because then that would tell me if it was 5s or 2s that I was getting. So 1 over 20s were actually giving me 0.05 if I do that as a fraction. So that tells me 10 to the -6. That's going to give me 50 kilohertz. So I use that to find out C. The next one then was a nice easy one about longitudinal waves. Remember, longitudinal waves, the direction of the wave, okay, the motion of the wave is in the same direction, so they are parallel. They are never perpendicular. So the direction of propagation of the wave is parallel, and the displacement of the medium is also parallel. All right, so again, a nice little easy one there. Question 15 was a little bit harder. Okay, now it's showing you 2 polarizers, but what you've got to think actually is that you've got 3 polarizers being used. The explanation of this is for answer B. So I'm going to go through and kind of use a different booklet here to show you how to get to that, and it is a little bit more difficult. So to get to B, we have to think about I0, I1, I2, I3. I'm going to use these just so I don't get muddled with the I0s going on. And I'm going to use it at 45 degrees, so that's an easy one to do. Well, I1 is half of I0, so I1 is equal to half I1, so I0 is equal to a half I1 there. I2, okay, has got to equal I1 cos squared theta. All right, I2 is going to be equal to I1 cos, that's just a 45, sorry. So in this case, cos squared of 45 is 0.5. So I2 is actually equal to a half of I1 when it's at 45 degrees there. So if I was to then use I3 to find out what the intensity is afterwards, I3 is going to be equal to I2 cos squared theta. So in this case, I2 is equal to half of I1. So I3 is equal to 0.5 I1 cos squared 45. Okay, so I3 is equal to 0.5 I1 times 0.5, which is equal to 0.25 I1. So again, if I was doing I3 divided by I2, which is the calculation that we've actually got, I1 over there, divided by I1, which is the one that we're being asked here. We're being asked I for this one, so that here is I3, that was I2, that was I1. Okay, so I3 divided by I1 was 0.25. We know at 0 and at 90, okay, that second polarizer would be horizontal and the first one would be vertical, so they're automatically going to give me 0 and 0. So I was using the graph, okay, at 0 and at 90, all right, we're going to get those shapes going down, and then at 45, it's going to give me a 0.25 intensity. So the answer was coming out to be B. All right. A lot of people may put down that this one just stayed being 0. If this was just looking at two polarizers, then that's fine. But this is looking at, if this was like here being unpolarized, that would be fine. But this is dealing with a, so this is dealing with three polarizers rather than two polarizers. So I hope that made sense, guys.